Hello everyone, it's Mr. Cablan here, and I'm here with the very first lesson for Chapter 8, which deals mainly with things like surface area and volume. But before we do that, we're just going to revisit something that I'm sure many of you have heard of before, and that's the Pythagorean Theorem. Believe it or not, most of you probably already memorized the formula, because again, it's a topic that's very popular when it comes to mathematics, especially in high school. So let's get straight to it here. So if you take a look at the diagram there, again, what you have there is an example of a right angle triangle. So Pythagorean theorem you can use only to solve for the length of sides of right angle triangles. So what we want to do here again is just to introduce what the Pythagorean theorem is, okay, reintroduce you to the formula, and to see and come up with a strategy to solve for the length of sides when you're provided with certain pieces of information here, all right? So as I said before, when it comes to the Pythagorean theorem, it only applies itself to right angle triangles. As you can see in the diagram over there on the bottom left hand side, there is a square which indicates that that corner is indeed a 90-degree or right angle. Now, the side that's longest on a right angle triangle is what's called the hypotenuse. Okay, and equally important is its location. So if you take a look at the box there and you look directly across from it, okay, that's the easiest way to find the hypotenuse. Now, locating the location of the hypotenuse is important, especially for triangles which may be in different orientations or different directions. So when in doubt, look for the box, look for the side across from the box, and that will always be the hypotenuse, okay? All right, so when we're looking at the formula for the Pythagorean theorem, okay, the formula for that is going to be c squared is equal to a squared plus b squared. Now, when it comes to labeling the letters with the sides here, the most important side that you need to label is the letter C, which is always hypotenuse. That's why when I approach questions dealing with Pythagorean theorem, I always label the hypotenuse first, because when you're labeling the A and the B for the other sides, it doesn't matter which one you label as A or B. As long as you label the hypotenuse as C, you can solve for the problems simply by substituting the numbers into the respective variables there. All right. So as I mentioned earlier, you can use the Pythagorean theorem to solve for the length of any sides in a right angle triangle, provided that you have two measurements given to you already. All right. So another thing we're going to look at, and it's going to be a good introduction to the remainder of this chapter, is being able to use a formula to solve for the area of a triangle, okay, using the measurements of a right angle triangle. So we're going to go through that as one of the word problems in this lesson over here. So we'll revisit that when we get to that example. All right, so to start off with just basic use of the calculator, just to familiarize ourselves with important keys that we'll be using for Pythagorean theorem. Okay, the first key that we're going to look at here is the x squared key. So after you substitute values in for the letters there, okay, what the square key does, again, it takes the number and then raises it to the exponent 2. Okay, and just do a quick practice. For example, if I wanted to do 9 squared, I just put the 9 in brackets. Okay, and from there, press x squared and then press equals, and that will give you an answer which should be 81. Okay, the opposite of squaring is taking the square root of it. So again, you just input it in the order that you see it. So to put in square root of 16, okay, you press the square root button and then 16 and then press equals, okay, and that should give you an answer of 4. All right, so that's just to introduce yourself to the calculator there. So let's get to it. So here are two triangles here. Again, just start off with a basic example. We're going to solve for C in question A over here, or example A. So always start off by writing down the formula first. So by doing that, since we have a C already, we're going to label the 7 to 4 as A or B. Now, just to show you, I can label the A or B for any of those remaining two sides there. I'm going to label the 4 here as the A and the 7 here as the B. Okay, and then simply just put the numbers in. Okay, and then from here, I'm just going to simplify the numbers inside the brackets. So 4 squared gives me 16, 7 squared gives me 49. Okay, and after you do that, add the two numbers together, and then last but not least, take the square root of both sides. Okay, and in your calculator, you'll just be taking the square root of 65 here. So what we have there will be an answer there of 8.1. Okay, and the units would be centimeters. All right, so for part B, if you take a look at the right triangle, again, for this question here, notice I flipped the orientation of the triangle here. Now, since we're solving for side B here, start off by writing down the formula. What I want to do here, since we're solving for on a side other than C is to label the C or hypotenuse first. As I said before, to find the hypotenuse, you just need to find where the box is or the square and look to the side across from it. So you can see in this example, the 15 here would be the C or hypotenuse. Now, since we have a B already, we're going to label the 9 here as A. Okay, now in the next step, we're going to put numbers into the variables accordingly. Now you notice if you compare this question already to the last one that we did, okay, the first step is already different, okay? We already have a value for C. So in the next step here, we're just going to simplify those numbers. So 15 squared gives me 225, and then 9 squared gives me 81. Now what we want to do here is to solve for this B over here. So we're going to leave it alone where it is, exactly where it is. So what we're going to do in the next step here is take the 81, okay, move it to the other side, and then subtract it from the 225 that's already there. Okay, and last but not least, in the next step over here, or the last step, we're going to take the square root of both sides, and this will give me an answer here of 12. All right, so those are the two basic ways to use Pythagorean theorem to solve for either C, or in the second example we looked at here, solving for B here. All right, so let's now take a look at some word problems that deal with this. But before we do that, I'm very picky when it comes to wording questions. Okay, so I'll always ask you to evaluate or solve for a certain variable. Okay, quite often at times the question might be ambiguously worded here, and you would get something like this. All right, I will never tell you to ever find x. Okay, this is not a wrong answer, but whatever you do not do that. Okay, so I'm, like I said, I'm very picky when it comes to wording of the questions. All right, so moving along here. Okay, we're just going to take a look at word problems here and how we can apply Pythagorean theorem to everyday life. So in this case here, one of my favorite type of questions, a ladder question, is that we have a 4-meter ladder, as you can see, and it's placed 3.5 meters up on a wall as pictured. So what we want to do here is to solve for side A. All right, so always start off by writing down the formula. Okay, so we have C squared is equal to A squared plus B squared. Now, since we have an A already, we have to do now is label the remaining two sides. Now, remember the first side that we need to label, or we should label, is the side directly across from the square there, because that's the hypotenuse. So in this case here, the 4 here is the C, okay, and our 3.5 here is our B, okay, and in this case, we're going to put the numbers in. Now, once you see in this step over here, this is very similar to the one we just did, and as I said earlier, as long as you label the hypotenuse as C, it doesn't matter what side you label as A or B, because the math behind it is exactly the same. So in the next step here, we're going to take the 4, I'm going to square it, and the 3.5, I'm going to square it. So we get 16 for 4 squared, and then 3.5 squared will give me 12.25. Now, in this step over here, we're going to leave the A squared where it is. So we're going to take the 1225, move the other side, and then subtract from the 16 that's already there. All right, and last but not least here, we're going to take the square root of 3.75, or take the square root of both sides, and that will give us an answer here of 1.9 meters. And don't forget, since this is a word problem, okay, please end it with a concluding statement. All right, so the next example we're now going to look at is we're now going to look at the area of a triangle. And what we want to do for this one is understand that the formula for the area of a triangle is given in terms of base times height divided by 2. Now, if you look at the triangle that we have here, we actually have to solve for the base first before we actually find the area of the triangle here. So we're going to do that first. So by doing that, we're going to use the Pythagorean theorem. And since we have an A already, okay, we have to now label the 2 remaining sides. So if you look at the square here and you look directly across from it, the 15 in this case will be our hypotenuse. So you're going to label that as C. And since we have an A already, the 11 here will be the B. Okay, substitute the numbers in for the variables, and then simplify. So 15 squared gives me 225, and 11 squared gives me 121. And since we're solving for the A here, we're going to leave the A squared where it is by taking the 121, moving it to the other side, and then subtract it from the 225. Okay, and last but not least, we're going to take the square root of both sides. Okay, and that's going to give us a measurement here for the base now as 10.2 meters. Okay, so that's step number 1. Now we now have all the information that we need in order to solve this problem here. So our next problem is to solve for the area using the formula base times height divided by 2. Now the base again is referring to the bottom of the triangle, so we're going to label that as base, and the height is the vertical distance of the sail here, the triangle in this case. Okay, that's going to be the height. So we're going to multiply those two numbers together and then solve and simplify. And I'm just breaking this down step by step here. So I'll just multiply the two numbers on the top together to give me 112.2. And since this is a unit of area here, our final units is going to be 56.1 meters squared. Now you're going to see in the remainder of the chapter here, determining the final units is equally important as the numerical answer here. Okay, so anything dealing with area, and later on when we're dealing with surface area, it's always going to be whatever the units are squared. So just keep that in mind. All right, so that wraps up this lesson here. So start practicing the Pythagorean theorem here. And guess what? I'll see you in the next lesson.